Alright, welcome to the third video, last part in this chapter number 5, numerical method. So the last part, we will gonna learn for the Newton Raphson method. So in the last video, I have shown to you one example on how can we use back the equation or the rule of Simpson as our approximation for us to get the value for integration or value for any under the graph for any function. And in the last part also, in the last part, it's slightly different from the last two method or two rule. So remember the two rule. So these first two rule is for you to get the approximation of area under the graph. And for the third one, for the Newton-Raphson or NR for short, NR, we will use this method by the Newton and Raphson. Okay, so this method is for us to get the solution or roots of any equation. Right, so let's get started. So before we start, what is roots of an equation? Right, so root, actually you have learned in your high school form 4. So roots is the value of x value when we have y is equal to 0. So let's say I draw a graph of quadratics, which is most of you familiar. Okay, you have x as this. Okay, so roots is in this part of the value. Roots is where our function cut through x axis. Okay. Right, so we have many ways to find roots. Okay, we can use factorize, we can use graphical method, we can use completing the square as well as the formula. Okay, so most of you guys are just familiar with EQN, right? Okay, actually EQN, this EQN, is the has actually all this formatted is in the function of EQN. So you need to know if the answer is da, we cannot use da. For example, if we get the answer in the whole number, the x is we can factorize. But if we get the answer is in the decimals points, which mean or even with the I imaginary number, which mean you cannot use method of factorize. So you have to use either formula or completing the square. Okay, right. That's what to share about the roots of quadratic equation. Okay, now we move on. Okay, so let's say we have this graph. Okay, I have graph of x squared minus x plus 10. And then I want to check. Okay, don't yet press EQN from your calculator. We just take random range. Okay, for example, I want to check roots between 8 to 10. Okay, so I just randomly pick number 8 to 10. So I want to check between the two range, is there root lies between the two range that I have picked, 8 and 10. Alright, so how to do actually very simple. So first we just simply replace x with 8 and x with 10. Okay, so you just find value of y by replacing x with 8 and 10. So we have 8 squared minus 7 times 8 plus with 10 equal, okay, so 8 square minus 7 times 8 plus 10, we get 18. Okay, next we do the same thing with number 10. So we have 10 square minus 7 times 10 plus 10. So we use calculator. So we have 10 square minus 7 times 10 plus 10. We have answer 40. Okay. So from now we have two answers, and the two answers here is both with the same sign, which is the positive value, 18 and 40. So if we try to sketch the graph by plotting the two values x and y, x and y, x and y, x and y into this one axis. Sorry. So I just plot the 2 points into one axis again. Okay, let's say I have so here is 8, here is 10, and we have 8 is 18, somewhere here 18, and 10 40 somewhere here 40. Just sketch, just assume. So if we draw a line connecting between the 2 points, we have this kind of line, which is it does not intersect between, it does not intersect for axes. Thus we can say that there is no root lies, no roots lies between 8 and 10, right? Between 8 and 10. Okay, so for the first range, I just pick 8 and 10 and I check there is no root lies between 8 and 10 by proving or by finding the y value, right? Okay, so now you can also try. You can try with the second range, okay, between 7 and 4, right? Okay, so you can try on your own, check the roots between 7 and 4. What can you conclude from the two range? Okay, alright. Now we have done this part, we haven't done checking. So you do part B, I just do for A. Same step, same approach, same graph for B, but different range, 7 and 4. Okay, put aside that. Next, we travel, we move to the next part. So we know from the graph here is lies our roots. Okay, our roots lies here. Let's say I have one guess value, which is 8. I pick any random number. 8 is our first guess value. So I will draw first the straight line to the y, corresponding y for x value. Then I will draw a tangent line. Okay, right? So this value of y, of x, sorry, is our second guess value, or x1. Okay, alright. So comparing the number is different. Okay, we do the same thing. So I zoom. Okay. So just keep aside first. So this side of the graph, I zoom in. Okay, we zoom in, then do the same thing. I draw the tangent line, and I will have this third guess value or the second iteration. Okay, and we will keep doing the same process until the tangent is converging to our roots. Okay, that is the idea for interaction. But don't worry, in your test or exam, you are not required to do this kind of graph. Okay, no need to do, don't worry. So in the part of calculation, you just use the formula. Okay, alright. So first, just get the idea how the numerical reactions work. Okay, so we have formula. You don't have to memorize. Okay, so this formula is for us to find the next guess value or the next iteration. Okay, so we have xn plus 1 is the next guess value or next iteration with xn minus with fxn. So function value when we insert x is with our first guess value divide by f prime. F prime is the first derivative from your chapter 1. Once we have replaced x with xn. Okay, so for example, in this topic introduction, alright, so it says in this example, use the interaction method to find the real roots of x cubed plus 3x plus 1 equal to 0 with initial approximation of x naught is 0 and give your answer correct to 5 significant figures. Alright, don't worry. So step number 1, you have to find fx. And fx must always equal to 0. So in this case, we have fx is x cubed plus 3x plus 1 as our x. Okay, here of x. Right. Then step number, you move on for step number 2. We have to get the f prime. Okay, f prime is we need to differentiate from your chapter number 1. Take a look your notes on chapter 1. So f prime will give us answer as 3x squared plus 3. Okay, done. Moving on, step number 3, we need to set the approximation. If the question does not give you the value of first approximation, so you can use any numbers that lies between the range, unless they give you the first or the initial approximation, you need to use the value that it gives in the question. So in this example, we already give the value of first or initial approximation, which is 0. So we have to use our x naught is 0. Okay, then step 3. Step number 4, we need to find the x value using the formula of Raphson. Okay, good? Right. Now we move on. Okay, so from the formula, we need to replace fx with the function used as well as f prime x. So I have replaced fx and f prime x with what we are being given and calculated for f prime, and then to find x1, which means our n is 0. So we have 0. Okay, so I will replace all the value for x0 with 0 with our initial value given here, 0. So we inserting all xn with 0, press the calculator, we get answer of negative 0.3333. Alright, and for this method, always use in the forms of decimals. I don't want you to use fraction. Why? Because decimal is much easier for us to compare the two value of x. Okay, so we take x0 and x1. So the two value is very far, is different. So we have to continue calculating or finding the x2. Okay, so to find x2, we need to use same formula, but with n is equal to 1. So when n equal to 1, we get x2 as our final answer. So by putting value of x1 from the last value, so just use back and insert to the same formula of x. Okay, I have what x1, 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 x1. Calculate using your calculator, you get answer of negative 0.3222 and 2. Alright? And we take the last two answer, comparing the two answer is not same yet, different, which means you have to continue doing for x number 3. Okay? Alright. So x3 we need to use n is equal to 2. So replacing x with number n with 2. So by using x2 from the last iteration, so put back the answer from the previous one, and we get the answer is negative 0.32219. And compare the answer, the last two answer compare is different. We have to continue for x4 again. Continue. So from here we get the answer is negative. We put back value of x3 into the equation of this NR, and we have the answer is negative 0.32219. Okay, comparing the last two answer here. Okay, so we have the same answer. Okay, so once we get the same answer, stop, don't continue. So just we have found our roots. So we just make one statement. Therefore, the approximate real root is negative 0.32219. Okay. Alright. So why do we get the same answer? Because of if you try to press the value for the in the purple box, we have the answer is slightly equal to 0. So when 0 divided by something is big, okay, we will get 0. Okay, so thus we just left with these terms of in the equation, and that's why we get the same answer for this method of integration. Alright? Okay, all good? Alright, clear. Okay, right. And that's all. Oh, sorry. That's all for the chapter number 5. And remember, chapter 5 will be tested for your test number 2, right? Then please try at least familiarize your knowledge. Make practice, do step by step. Don't need to skip. Just follow the step I have taught in this video, and inshallah you can do very well in this chapter number 5, which is very easy and alright. Okay, I think that's all for this lesson, this video. I hope you have a good day and have a wonderful day ahead. Alright, bye. See you in the next video. Alright, good.